Okay, so let's play a fun little game. Go ahead and pick any number you want, any natural number, so any counting number. So that number is going to either be even or odd, right? Any natural number, any counting number has to either be even, meaning it's divisible by 2, right? 2, 4, 6, 8, 10, 12, 14, and so on. It's either even or it's not divisible by 2, and therefore it's odd. So we're going to pick any natural number we want, and then we're going to just have this simple rule. If the number is even, we're going to divide it by 2. So pick any number you want, just call it n for number, and then if the number is even, we are going to divide that number by 2. Now, if it's odd, well, if we divide it by 2, we get a fraction. So that's going to make things probably even a little harder. So let's not have fractions. So instead, if it's odd, we want to multiply it by 3 and then add 1. And then doing so will actually make it even. But okay, so those are only two rules we have. Either the number is even, if it is, we divide it by 2. If it's odd, we multiply it by 3 and then add 1. So I guess we can have this little expression here, right? If the number is even, we have n divided by 2, so n over 2. But if it's odd, well, we have 3n plus 1, meaning we multiply it by 3 and then add 1. Okay, so what we end up with would be some kind of sequence of numbers. And we do this rule, we keep doing it again and again. If the number becomes even or odd, we follow one of these two rules. So let's pick some number. I don't know, what's a nice number? How about let's pick 10. So if we pick 10, well, 10 is even, right? So we start with 10, okay, and then we get a sequence of numbers. So we can do this, most of this you should do probably in your head. So let's do, and using calculator is totally fine too, but I think it's good practice to kind of do this in your head, and it's kind of fun. So our first number we're picking is 10, okay, so 10 is going to be even, so we divide it by 2. Well, dividing it by 2 is half of 10, so this is 5. So our next number in the sequence is 5. Okay, and then 5 is odd. So we multiply it by 3 and then add 1. So 3 times 5 is 15, and 15 plus 1 is 16. So our next number in the sequence is 16. Okay, 16 is even, so we divide it by 2. So that would be, well, half of 16, which is 8. Okay, and we're still even. We divide it by 2 again. So 8 divided by 2 is 4. Okay, we are still even. So we divide it by 2 again, and we get 2. We're still even. So we divide it by 2 again. So 2 divided by 2 is 1. Okay. Oh, and now we're odd. So if we wanted to keep going, which we could, we would multiply it by 3 and then add 1. Okay, but 3 times um, 1 is 3 plus 1 is 4. Oh, okay, so we're at 4. Okay, well, let's go back to this number. So we could go, I guess, 4. Okay, but then, well, 4 is even. So, okay, divided by 2, we get 2. And 2 is even. So, okay, they can get 1. And then, okay, well, 1 is, okay, odd. So times 3 plus 1 is 4. And we see what's happening here. Divided by 2, we get 2 and then 1. And we keep going, right? So we ended at 1, and then we end up in this basically infinite loop. We just go around and around. We get 1, and then 4 2 1 4 2 1. So we started at 10, and we could say we actually ended at 1, right? Once we hit the 1, we get an infinite loop. Okay, so we ended at 1. How about we pick a different number? Um, well, if we pick a number, 5, 16, 8, or 4, or 2, or 1, we're obviously going to end up in the same cycle. So let's pick something else. What are you thinking of? I don't know. Um, how about, I don't know. Um, how about, what do we think? Maybe 12. Let's pick 12. Okay, so 12 is even. So we divide it by 2. And what do we get? We get 6. 6 is even. Divide that by 2. We get 3. Okay, 3 is odd. So 3 times 3 is 9. 9 plus 1 is 10. Ooh, but now what happens? We're at 10. So now we know the next number in the sequence is going to be 5, and then 16, and then 8, and then 4, and then 2, and then 1, and then we see we're in an infinite loop again, so we ended at 1. Okay, so we started at 10, we ended at 1, we started at 12, ended at 1. Pick another number. Okay, I'll tell you right now, you're going to end at 1. Okay, pick another number. You are going to end at 1. So you're probably saying, okay, well, so every number ends at 1. And we think that's probably true. It's a famous problem. It's actually called the Collat's conjecture, um, which basically just states that any natural number you pick, now there's infinitely many, right? Numbers go on forever, will always end at 1. We think. We really don't have much of a clue as to why that seems to be the case, or it is the case for every number that's ever been tried. But if you can find a number that does not go to 1, right? It goes off to infinity, and maybe cycles in some other, you know, cycle, which doesn't end up coming down to 1, or you can show that every number does, you will be rich and famous beyond your wildest dreams, and have solved one of the hardest problems in all of mathematics. So, this, as easy of a problem as it is to state, is actually an unsolved problem, which will probably be unsolved well, it's been unsolved for quite a long time. And there have been, right, many problems in mathematics that have been unsolved and they have now been solved. They've been solved very, very recently. This one, on the other hand, though, as easy as it is to state, is seriously, um, I can't explain to you how hard this problem is. But if you want a challenge, um, try to show that every number will go down to 1, or find a number that doesn't. All right, have fun. Take care.